So now that we've learned a little bit about influence from one individual to another, I'd also like us to think about influence from one neighborhood to the next, one location to the next. It's really the same idea, but there are some important nuances or twists here. So the unit of analysis that we could be talking about could be a zip code or a city block or even a whole town, but we want to think about, when we think about acquiring customers and lead users, how there may be a process of spreading from one location to the next, whether it's a physical neighborhood or also a virtual neighborhood. So I'm going to do this by way of an example, and it's a little bit technical, but I think if you follow along, it'll be very useful because it's such a central concept here. So on the slides, what I'm showing is I'm showing a diagram that has four pieces: left, right, bottom, and to the right-hand side. And I want you to think about at the top left, you see three entities. We'll think of these as neighborhoods, but they could also be people. So there's Z1, Z2, Z3, Z4. Or if you prefer, my original native tongue from New Zealand, I would say Z1, Z2, Z3, Z4. So those are the four locations. Now notice, all of those four locations are connected to each other. They could be zip codes within the United States. They could be people on a social network. Now, in order to understand how something spreads through those neighborhoods by a process of influence, we first of all need to understand who is connected to whom, or which neighborhood is connected to which one. So now let's move down to the bottom left, and let me explain that little matrix there called C. You've probably seen matrices and things before in high school and other places, but sometimes it's good to refresh our memory of what this means and what it means in this particular context. So the letter C stands for contiguity, the word at the top of the slide, which just means things that are next to each other or touching. They are contiguous. So let's start by focusing on the first row, and then I'll do another example with the third row. So row number 1 corresponds to Z1, zip code number 1. Now what we see is column number 1 has a 0 in it. That's just a convention. That means that zip code 1 is not connected to itself by definition. And in fact, if you go down the matrix, you'll see all the diagonal numbers are all zeros. That's just a convention that says zip code 2, row 2, is not connected to zip code 2, column 2. Now if we move row 1, column 2, we'll notice there's a 1 in there. Why is there a 1 in there? The reason there's a 1 in there is that zip code 1 is connected to zip code 2, so we put a 1 for that combination. And similarly, when we go to column number 3, there's another 1 because zip code 1 is also connected to zip code 3, but not connected to zip code 4. So you can repeat that process for the other 3 rows, and then you'll see all that really is saying is who is connected to whom, or which zip code is connected to which other one. So now let's just move across to the bottom right-hand side and focus for a moment, please, on row number 1. Notice on the bottom left in row number 1 are the numbers 0, 1, 1, 0. What that means is that Z1, zip code 1, has 2 neighbors, zip code 2 and zip code 3. Now since zip code 1 has 2 neighbors, one of the simplest assumptions we could make is that zip code 1 is receiving half of its influence from the first neighbor and half of its influence from the second neighbor. If we move down to row number 2, we notice there that the numbers have changed from 1s to 1/3. Why is that the case? Because zip code 2 has 3 neighbors. Notice that zip code 2 is connected to all other 3, and we could assume in the simplest possible case that if I have 3 neighbors, one is exerting 1/3 influence on me, the other one's also a third, and the third one's also a third. All of my neighbors have equal influence on me. This is the simplest possible case, and of course in doing research we could relax this assumption, but I just want to give you a flavor for the mechanics of how one actually studies a process of influence and a process of contagion. So now just move up one more to the final piece of the puzzle. There's something that's called YZT-1. I know that sounds like a mouthful, but you can see it there on the screen. That's an indicator, Y, for zip code Z at T-1, that means the previous period, of whether some activity that we're interested in has actually happened or not. So we might be interested in whether or not in that zip code, at some point before the last time period we looked at, had anyone bought anything from diapers.com. If the answer was yes, we say 1. If the answer was no, we say 0. Okay, so now we have all 4 of the elements, the diagram, the first C matrix, the C matrix that's standardized, and then also the vector of 4 rows and 1 column that's summarizing the past activity of either the people or the neighborhoods that we're interested in. Now, in the next couple of slides, that I'm going to put in the deck so that you can see. They're a little more technical. I know some of you out there like the technical material, but it's not necessary for understanding what's going on. All I'm going to do is I'm going to take those two pieces of information and I'm going to combine them in a statistical model to understand whether or not there's any contagion or any influence taking place. So, some of you may have looked at the technical material on the next 3 slides, but if you didn't, it doesn't really matter. The main thing to take away or to understand from this conversation so far is that when you're measuring influence, either between individuals in a social network or influence spreading from one neighborhood to another as they adopt some certain product or service, you need to understand 2 things. First of all, who is connected to whom, or which neighborhood is connected to which other one, and what has happened so far with respect to the activity. If you know those 2 things, who's connected to whom and what's happened, you can combine that information and do some very, very interesting research with it. So now let's get to the 4 research studies that I mentioned at the beginning. I'm going to go through them one at a time and explain the different things that we learned from this process about the degree to which customers influence each other and how that actually helps the firm or the seller. So the first study, study 1, is looking at neighborhood to neighborhood influence and how people come to try an internet grocery retailer. In this case, it's called netgrocer.com. Below there on the slide, I've put the abstract from the paper that I wrote with my friend and co-author Sang-Young Song. Sang-Young is there in Korea at Awa University. So what we did is we studied how netgrocer.com spread its sales throughout the United States after it opened its business. So what I'm going to show you now is some maps of how netgrocer.com acquired its customers over space, over the United States, and over time as the business evolved in the first 3.5 years. I think these maps are really pretty cool because we can see some interesting behavior of customers going on underneath the map. The same kind of thing I've also observed when I've looked at other internet retail businesses like diapers.com, warbyparker.com, and so on. So let me put up the first map and explain what's going on here. This is a map of the continental United States, 48 states except for Alaska and also Hawaii. Now what you'll see in the map is that there are some areas of the map, little dots or squares that are darkened in a dark brown or a black shade depending on where you're watching this. What that means is in that location there was at least one order to netgrocer.com within the first 6 months of operation. Now I should say that NetGrocer opened in May 1997, and in the first month that they opened they shipped out 34 orders to different places in the United States. This is now looking 6 months out. Now as this goes through, just compare to the next map, we're now 18 months out. The first thing you'll notice is there are many, many more dark shaded areas, meaning, wow, NetGrocer has somehow acquired customers in a lot more places than it had after just 6 months. If we look after 30 months, the map's getting darker still. And then finally, after 42 months, there's an incredible visual of almost most of the United States, or at least 20,000 zip codes that are all shaded brown, meaning at least one person has made an order in that zip code. So the question that you might have, and the question that Sang-Young and I had was, is there any kind of special structure to how this is happening, or is it just happening randomly? So at the top of the slide, we see 42 months, and we might scratch our heads and say, I wonder where the new customers are going to show up in month 43. Would they just be random darts on the map, or would there be some way to predict where they were more likely to come? Now, in order to answer that question, we went back to that material that I showed you earlier, the example with the 4 zip codes, and we did all of those computations, not just for 4 zip codes in a neighborhood, but for all of the zip codes in the entire United States. But before we ran that analysis, I just want to show you, before I show you the results of that analysis, I'd just like to show you the data at a little bit of a closer level of detail. So what I've done is I've split the screen left and right, with the left half being the west coast of the United States and the right half being the east coast of the United States. You can see New York and Philadelphia there. Now again, this is in month 1, May 1997. Notice that NetGrocer had some customers near the San Francisco Bay Area, I think one down there in Los Angeles and some other on the East Coast. Look at what happens as we proceed through month 2, then month 3, then month 4. Are you noticing any kind of a pattern here? Let me do one more, month 5, and now month 6. And so on, spreading out all the way to month 45. What you might have noticed, and I think is fairly clear from the visual, is that the areas that turn dark, that have new customers, tend to be close to areas that already have customers. So let me just say two things here that could be going on underneath this pattern of data. So first of all, it could be the case that my friend Chris and I live in a similar neighborhood in Philadelphia, and because we're friends, I happen to tell him, hey Chris, you should try netgrocer.com or diapers.com or warbyparker.com or whatever that is. And because I've told him through word of mouth, he then ends up adopting the product too, and that's why you see the sales patterns spreading through this proximity or contiguity. Secondly, there could be information that gets transmitted not through conversation, but what I'll call through just direct observation. This one's very interesting. Let's say I order the box from netgrocer.com or Amazon or Warby Parker or Harry's or whatever company I'm thinking about, and the box comes to my apartment building. And Chris, who lives in the same building, even if he and I don't know each other, maybe he sees the box, and as a result, he then goes on to order. So that's why packaging is so important for e-commerce companies, because it's a little bit like advertising and distribution all rolled into one. Second interesting thing to think about here is where the product gets shipped can also play an important role. So for example, if you think about a company like birchbox.com, very interesting business that will send both men and ladies, but the original business was just for ladies. For $10 a month, you could receive some samples of makeup that you might want to try and then later purchase through the website. Now, if those boxes get delivered to your office and you open them at the office, other people see them, you can imagine what might happen then. A conversation ensues about the product. So for an e-commerce company, even thinking about where to ship the product is very, very important. So just to wrap up this study, what Sang-Young and I did is we ran a huge statistical analysis with millions, literally millions of observations. And what we tried to do is we tried to control for all of the other things that would explain why in one zip code, netgrocer.com was stronger, and in another one it was weaker. So you might imagine what those things could be. They're things like the demographics. So in neighborhoods where there's higher income, higher levels of education, more access to the internet, probably NetGrocer would have higher sales. So what we wanted to do is make sure that we equalized all those things or held them constant in a statistical sense. But after doing that, we found there was still a persistent effect of this so-called contagion. And the contagion actually was very, very powerful and very, very helpful to the company or to any e-commerce company. And we actually computed from our statistical analysis what the effect was and how beneficial it could be for the firm. And I've put an example there for you on the slides. So it turns out in the United States that the average zip code has about 8,700 people, and it has about 5.6 neighboring zip codes. So that's just the fact of the data. What we did is we simulated what would happen to a zip code that currently had no customers at netgrocer.com. Well, that zip code has about a 3% chance, if it has none right now, a little under a 3% chance of some customers showing up in the future. However, if in its neighboring 6 or 7 zip codes, an additional 20,000 people try, then the pressure to try in that zip code where there's currently no customers goes up to about 14%. And this is economically very, very important for the firm.